Hello everyone and welcome back. So now that we've taken a look, the theory behind value noise, in this video Lee is going to begin the implementation of a value noise 2D. This is part one of the implementation.
Right, we're going to need to do some initial setup to get things in place to handle the value noise, but it's also going to be the groundwork for our Perlin and Simplex noise when we get to those as well. So if I go ahead and jump over here, try to get
Oh,
the little thing to pop up, but it won't.
there you
Thank
go.
you.
You're welcome.
We'll switch over. I want to do a little bit of project management over here inside of scripts. I'm going to create another folder, and I'm going to name this folder noise, and this is where we're going to keep all of our noise related classes. I'm just going to close this guy. I don't want him there. I don't need the reference, don't need any instructions here. Oh, by the way, this apparently worked, so I didn't need this line anyways, so I'm going to clean that up while I'm here. Don't you love the way ADD works?
All
right.
That.
So back to where we were going. We're going to be using partial classes. So what I want to do is break up each of the different noises and the code that goes with those noises into each of their own files. But I want all of the noise to be covered inside of a single class. So to do that, we can use a partial class, which makes things nice and organized. So we'll go ahead and we'll start with our first CS file, and this will be noise. Once again, original naming to the rescue. And we'll create a second CS file, and this one will be called value noise. I bet nobody saw that one coming.
Yeah, I didn't.
So these will give us our two files. Now, for now, just do a little bit of cleanup. And for this, I want to make it a public static partial class. And this class is going to be called noise. I'm going to take, this line, copy it, go to noise, and I'm going to paste that down here. Clean up our namespaces.
Ooh, look at you go, finally. I always bite my tongue when you go up there and highlight all that and hit delete.
Yeah. Well, you know, I've seen a couple of complaints where people are going, yeah, you hit some magic keys and things disappear or appear.
I know.
And they're miss it. So I kind of go back and forth.
But these aren't regular training VTMs. These are us just doing R&D, and we can work however we want, say whatever we want.
This is true, but I do a lot of R&D type stuff just out of habit, and other things that I show pretty much every step just out of habit.
I know.
So, but I try to accommodate both worlds. All right, so now what we've got are two files that are using partial class to make up a single class. So I can put it in methods and properties in either one of these files, and they'll be available to me as if they were inside of a single file. That's, in essence, what partial does for us. Now, for value noise, we're going to need a property called, so I'm going to make a public static property. And this, not statif, we're not in Russia. So static integer, we'll call this seed, and give it its getter and setter. Now, we need a seed because our value noise is going to rely heavily on random numbers. And our random numbers that we've created before inside of our myRandom class, specifically these hashes down here. And I'll get down to them. Yeah, our hash 2D and our hash 3D, both of which take in a seed in addition to the X, Y, or the X, Y, and Z locations. So this is the seed that I want to be able to set inside of noise. And I want to be able to allow the user to, or the programmer to go ahead and change this when they need to. So we're going to have a property for that. I also want to have a static constructor. So this will be static noise. Not going to take in anything, obviously. And we're going to seed and set that to 543. Just a number off the top of my head. You can make it anything you want. I just want noise to have a predefined seed, so if nobody sets anything, we get something.
Mm-hmm.
So that's what this does. Now, for now, this is all we're going to need inside of our noise CS file. When we revisit this with Perlin and the simplex noises, we'll need more stuff as far as properties and information. I don't really want to get into what that information is, but thinking about it, because I don't have my demo framework, we are going to need one additional method. This would normally go into the utils file, but we don't have it here, so I'm going to just throw it at the bottom of the noise function for now. This is going to be another public. Actually, nothing needs it but itself, so for this case I'll make it private. We'll do a private static. It's going to return an integer, and this is going to be a floor function. So just a little bit faster way of implementing a floor as opposed to the math or mathf. So what we're going to do is return if x is greater than 0. We're going to return the integer of x. Otherwise, if, oops, this is what happens when you look at your keyboard and not the screen. So if x is less than 0, we want to return the integer of x minus 1. Now, what this is doing is, if you just take in a double or a float, something that has a decimal place or a fractional component, and you cast it to an integer, it pretty much just truncates anything after the decimal place completely off and returns it. That's great if you have a positive number. So if you have the number, say 4.5, and you cast it to an integer, what you get out is the number 4. Where the problem happens is if you have a negative number, say negative 4.5, and you cast it to an integer, what you get is negative 4. And because we're looking for the floor, or the lowest possible whole number related to our number, what we want is negative 5. So what we do is we cast x to an integer. If it's negative 4.5, that would give us 4, and then we subtract 1 with it, which gives us our next lowest whole number, which makes sure that what we're trying to do is make a unit square in effect, and we want to be able to make sure that our whole numbers that define our unit square contain our x and y location inside of that unit square. So that's what this method's going to do for us. Now, we jump over to value noise. If you remember in the last theory video, we were talking about needing a couple of different things. Do we have that site open? Or
No, not at the moment.
all right. I'll click on it, and if it shows up on one of your other monitors, could you bring it over?
Mm-hmm.
Did it open?
Yours did. Well,
Huh?
your machine. Here you go.
No. I clicked on your button.
That's what you. Whoa! Hang on. We're fighting over the mouse. All right, there you go.
So we'll go back to the Perlin noise, not the Perlin noise website, but the value noise Perlin noise website. See my last video for explanations. I kind of beat that into the ground, I think. So I don't want to go into that too much. But one of the things when we're discussing this website is there's essentially two different things that we need to accomplish when sampling for a value noise. We want to be able to get a random number, but we want to smooth it. We want to smooth it so we're taking our corner positions and then we're adding those together and dividing by 16. We're taking our side locations, sampling those, adding them together, dividing by 8, and taking our center sample and dividing it by 4, adding all of those together. What we're trying to do is take the really noisy white noise that we would get. I'm trying to scroll up. If you remember when we just pulled the information from the hash, from our hash2d function, we had something that looked similar to this, but ours was white and black. It was a lot of high frequency noise, just a whole bunch of dots. And what we want to do is we want to smooth this out so it doesn't look as high contrast or as harsh as this is. What we're aiming for is to take all of our noise and be able to smooth it out so we get some sort of sinusoidal type noise wave that looks a little bit better. So smoothing out our noise is the first step in that process. So we need to write a smooth noise method to handle that. And my daughter is coming in the door.
All right, well, hang on 1 second so you can update her that we're recording, and I'll just pause this. Here we go.
Okay.
All right, and we're back from the quick pause, so we shouldn't have any more interruptions. And Lee, I'm handing it back over to you.
All right. Inside of value noise, I said we need to implement the smooth noise. So let's go ahead and start coding that up. So we're going to make a private static. This is going to return a float. We're going to call this smooth noise. And it's going to take in two values, an integer x and an integer y. And then some squiggly braces and time to do some stuff. Now we need to calculate in the contributions for the corners, the sides, and the center. So we'll start with the corners. So var corners is going to equal, inside of brackets. Oh, come on. Seriously? Wow.
You can do it. Delete and delete.
Yeah, but I'm going to come back later because it's just going to keep doing that and annoy me until it's sometimes works, sometimes not. All right, so what we're going to do is we're going to be pulling from our hash2d. So we're going to call or leverage our myrandom.hash2d. Now, it requires a seed. We've already made a property called seed. So we're going to use that. We're going to basically be sampling in a square pattern around our x and y. So assuming that x and y is our center spot that we're sampling, we want to sample one number to the left and one number above, so in each of the corners. So we're going to go to the upper left, upper right, lower left, and lower right and sample each one of those positions. So we're going to start off with x minus 1, comma y minus 1. And we're going to be doing this 4 times. So I'm going to just copy this bit of code and hit Control V a couple of times. Tab this over to clean it up a bit. And get rid of this last bit here. And we want to divide our result by 16. I'll make that a float. Now we need to go fix our offsets for each of our sample points. So we're going to, this one, x minus 1 and y minus 1 is our upper left. I want to get upper right, so that'll be x plus 1 and y minus 1. We want to get lower left, so that's going to be x minus 1 and y plus 1. And, or actually, I'm saying that. Let me try to think about that. Well, I get confused because Unity sometimes samples with the lower left being 0, 0, and some things are 0, 0 being in the upper left corner. So I get those backwards from time to time. So this is either the lower left, or sorry, the lower right or the upper right, depending on how you're indexing your space. So this will be all 4 of our corners. Now the nice thing is we can copy this same code again, but instead of corners, this will be our sides. And our sides are going to be sampled at x minus 1, x plus 1, and y plus or y minus 1 and y plus 1. So these are going to be halfway between each of our corners on the sides. And we're going to divide this by 8. And our last sample point that we're going to be checking is going to be our center. Center is going to be my random.hash2d. Again, seed x and y. Divide it by 4f. And we want to return a float of the sum of corners.
Karuners?
Yeah, I'll get to that. I was looking at my keyboard.
You gotta learn to type, Lee. I'm sorry, man.
I type pretty fast considering the fact that I'm not touch typing and only using 3 fingers. So, all right, so that will return this. Now, right now, this is marked as private because technically outside of our noise, nothing should ever really sample smooth noise. But I want to look and see what kind of result we're getting from this. So what I want to do instead of making this private for the moment is I'm going to make it public after I fix my spacing. So we'll switch this up to a public for now. And let's go back to Game Manager real quick. Now inside of here, change this. I don't need to divide by 2 anymore. And I want to use the 2D version of this information, so iteration is not going to be used. But we're also not going to be using the myrandom hash 3D here. Instead, I want to look at noise. Whoops. Noise. Hit escape. Find it. Create method. Oh, is it not going to find it for me? All right, so we'll create it by hand. Using, if I remember, it's underscore scripts.noise. There we go. So using that, now I should be able to go noise.smooth noise. I don't need to send in a seed because we've already got that configured, but I can send in my X and Y and it's going to return a float. So in that case, I don't even need to cast this to a float. So if I build this...
Hang on.
Oh.
There you go.
I know what happens, what causes that when I hit the build sequence.
Mm-hmm.
So if I screw up and hit Control-Shift-B instead, that's what brings that up.
Gotcha.
All right, so if we switch over to Unity, now we should be using smooth noise instead of our high grain noise. So as you can see, instead of getting that really harsh high contrast noise, we get this nice little smooth.
Almost looks like a Gaussian blur has been applied to it.
Technically, it's called a box blur, is what we're doing.
Very cool.
So we are doing a box blur. Now, one of the things with this is if you look, we can almost see a 1 pixel artifact around the edge.
Yeah.
So it's kind of hard to see. But that's also, let's see, am I doing 256? I also think it might be partially responsible by the fact that I'm still upsampling. So if I go back up, yeah, we're still upsampling. So if I change that, we try this again. So we're still getting some softening, but we got rid of the artifact around the edge. So just for comparison, if I go back and let's see, go to
the right
code. Yeah, well, I got sidetracked. But down here. So far n equals my random dot hash 2d 20 comma x comma y. No, let's do the 543 because that's the seed that I'm passing in by the noise by default. So I'm going to use the same value noise. I got to cast this to float. So now if we run now, because this is a one iteration box blur, it's subtle, but you can pick up the difference from here.
Well, you're seeing a bit of encoding as this is being passed over
Right.
TeamViewer. It's actually pretty darn sharp. I mean, it's...
But if I hit print screen right now, or actually, I don't know if this will pick up on yours, so I'm going to try. Can you hit print screen on your keyboard as well?
Sure. Hang on.
And then bring up Photoshop.
Absolutely. Hang on a second. Let me do something else. Let me go back over to this and make sure I'm inside this window. There we go. And jump back over to Photoshop. They didn't need to see all the junk I've got open on all of my monitors. And let me go ahead and crop this out for you.
Yeah, cool. Thanks. Save me some time.
Good enough. It doesn't have to be perfect.
Nope.
And and hang on. All right, so we've got this guy, and let's go ahead and switch back to here. Stop, because I know where you're going with this.
Yeah, I want to, because it's kind of hard flipping and going,
Sure.
yeah, okay, see how it's softer? And it's like going, might as well just do two print screens. We'll do a side-by-side comparison, because this is a subtle effect, but you can definitely see it.
Oh, on my end, I can see it very well. I just don't know. I know for
how
you,
well they're going to get it.
For you, it's going to be a little more difficult to see, and for our viewers, where the actual video has been encoded, yeah, it's very noticeable.
Yeah, and I think even with the encoding, once we've got these images cropped side by side, they're going to be able to tell.
Yeah,
very quickly.
For sure. Oh, good enough.
All right, so now if I Control A, Control C this, go over here, and it's Control Shift C, I think. Or is it not? Canvas size. Oh, Control Alt C. My bad. So let's go to percent. I want to raise percent by double. Move it off to the right. Hit Control V. Paste off my image. Switch to V.
Here, let me center that up for you.
Yeah, thanks. I was like going, no, it's not working.
There you go. Good enough.
But you can see.
Can you see it now?
Yeah, I can see it.
Okay.
But it is subtle. But the image on the right is much blurrier than the one on the left.
Absolutely.
So hopefully it picks up on the encoding. It should.
It should. Yeah, that's a pretty noticeable difference in my opinion.
Right. So, but what we've done in essence is done a box blur to each one of our samples. Now, this is also kind of the reason why value noise is so slow. Because if I jump back over into code,
let's go ahead and pause out of this.
Stop playing.
Yeah.
So if we jump back over to code inside of our value noise, we're just doing a 2D noise, but we're already having to sample 9 different noises and average all these together to get a single noise value.
And obviously
And
that gets expensive.
right, and we're not even done yet because that is just a smooth noise off of our hash. We still have to interpolate between each one of the points of our curves.
Hmm.
So we've still got a bunch more operations that need to be performed just on the 2D. Now, if you look at when we get to the 3D, the number we have to double the number of samples in each one of our corners and sides, because instead of 4 corners and a 3D unit cube, we have 8 corners, and we end up with a total of 12 sides if we sampled all of them, but I'm going to cheat and only sample 8 of them.
Hmm.
So we're just doing more and more and more operations. And then when you consider the fact that a 1024 by 1024 image has roughly a million points that you've got to do, it gets very intensive very quick. So, but I just wanted to point that part out. And that gets us where I wanted to get in this video.
Okay.
In the next video, we'll actually implement the interpolation between each of the sample points.
Awesome. All right. Well, with that, that's going to conclude this video. Thanks a lot.